Okay, I'm going to go ahead and give you a kind of introduction to charging. Now, this is a great way that we can show some of those forces that are exerted between different charged objects. So in order to talk about some of those demonstrations I'm going to show you, I'm going to need to first get some ground ideas down. So the first thing we need to know is that like charges, they repel each other. Opposite charges attract one another. And they use Coulomb's law to describe that, meaning that the force is dependent on how big the charges are and how far apart they are. Again, the further apart they are, the less the force is. The closer together they are, the bigger the force is. And same thing with the charges. The bigger the charges, the bigger the force. The smaller the charges, the smaller the force. So the first thing we're going to do then, after we get that idea of like attract or like repel, opposites attract, is that we have conductors and insulators. Now, conductors, they allow charges to easily flow. Now, typically when we talk about the movement of charge, we're talking about electrons, not ions. And insulators, they don't allow those charges to move easily. And now there's going to be a whole kind of gradient from conductor to insulator. And so we're just going to talk about them in more of that general sense, though, that one, they can easily flow, the other one, they cannot easily flow. So the first thing we're going to use to set up our charge is we're going to use cat fur and a plastic rod. Now, it's not really cat fur, this is from a rabbit, but we use the word cat fur here to refer to the fact that this is going to be the positive charge. It's going to be the cat ion there. So as I rub those together, what I'm doing is I'm stripping electrons from that fur over to my plastic rod. So now what I've done is I've removed electrons and I've placed them on this plastic rod. So now I have a negatively charged rod and a positively charged fur here. Okay, so now with those things kind of set up, so now I can see, all right, I have a negatively charged rod. And when this was first developed, it was just arbitrary. We did not make positive or negative for any specific reason. It was very arbitrary. All right, so first one we're going to look at for a type of charging for demonstration purposes is polarization. Okay? Polarization is only the separation of charge on something. Now, if it's a conductor, those charges can easily move. They can move long distances. If it's an insulator, they can't very easily move. They might only just kind of rotate in place. Okay? So we're not going to get as big of a difference in the charge on something that's polarized as an insulator versus polarized as a conductor. So there is this separation of charge, but there is no net overall change in charge. If the thing was neutral before, it's still neutral afterwards. If it was negative before, it's still negative afterwards. Polarization just separates the positives and the negatives to some degree, remember. Okay, so here we have, I'm going to go ahead and I'm going to show you this demonstration in a second here. I'm going to bring in that negatively charged plastic rod, and what it's going to do is it's going to repel all of those electrons, and I'm going to do this with something that is a conductor, meaning those electrons are going to be free to be pushed away. And so the closer I get this wand, the harder I'm going to push those electrons away. Now those electrons are going to build up over here and give a back pressure, if you will, to other electrons trying to move over there. So I'm going to get a gradient from positive to more negative as I get close to it. Now what you're going to see here is that this more positively charged side is going to be attracted and this negatively charged side is going to be repelled. But overall, it's going to have an attractive force, and that's because the force is dependent on the distance. So the further things away have less force. The closer things have more force. So the force from the positive side is more powerful than the force from the negative side, and so I get this net force of attraction here. And so let's go ahead and let's take a closer look at that here. All right, let's take a look at this demonstration we got here. So I have my cat fur, or my rabbit fur here, and I also have my charging rod. So we're going to go ahead and charge that up. So now I have the negative charge on here, and we're going to bring it close in to these. Oh, you see it attract over there. And so it attracted, so what I did is I polarized it. It became attracted, it came over, and as soon as I touched it, we got some conduction to happen, and so that's what happened there. So let's go ahead and polarize this one as well. So I can polarize this one, so I bring it in, And as I bring it in, I'm pushing those electrons down into those leaves. And what happens is those electrons, once they get down into those leaves, go ahead and repel each other. Okay, so I'm polarizing. I'm getting positive up here, negative down here. All right, let's go back to the board and look at conduction next. Okay, now that we saw polarization, we're going to look at the next type, which is conduction. For conduction, you need contact. The two things need to touch. And when they touch, there's a transfer of excess charge. Okay? And after that transfer of excess charge, afterwards, they're going to have the same charge. Now, when I say same charge here, I mean they're going to have the same sign. So if the thing I touched it with was negative, the other one's going to be negative, okay? So the example we're going to look at is we're going to look at that electroscope again that we polarized earlier, and we're going to go ahead and touch it with the negatively charged rod. Now this negatively charged rod is an insulator, meaning all of the charge is stuck on the outside. It cannot easily flow off like into my hand as a grounded source. It just stays there. But when I touch it, all of the electrons that are right on that touching edge are now in contact with something that is a conductor, and those electrons are then allowed to flow. Now, as soon as they get to an easy flow situation, all those other electrons repel it and they get pushed down into the bottom. So as soon as I touch it, a bunch of electrons hop off and move down. So I was already polarized, so I already had a positive here attracting the electrons on it, and I had the negative ones being pushed down. But now I've added more negative. I've changed the overall charge of that electroscope. And then when I remove it, some of those electrons come back up and match up with those positives, but overall I have some extra negative charge on it. And so those leaves we're going to see are going to actually stay apart. So I'm going to still have charge on there. Okay, so let's go ahead and take a closer look at that electroscope and how it's charged with conduction. All right, we're going to look at conduction. So in order to get conduction, I'm going to need to touch that rod. So I'm going to charge it up, get that negative charge on there, go ahead and touch it. And when it touches it, you'll notice that those leaves separate apart. They move apart. They are repelled. There's extra electrons all over. Now I can prove that it's negative because when I bring that negative rod in, I'm going to push electrons down into those leaves, and they're going to repel each other even more because there's more charge down there. So it's going to get a larger repulsive force. All right, let's go back to the board and look at our last one, induction. All right, now we're going to look at induction, the last type, which is kind of a combination of these. So how we do induction is we do something called grounding it. Now, grounding is when you attach it to a source that has an infinite amount of charge. Now, that's kind of a relative term, infinite here. So it has a very large body of charge. So if you add charge to it, it doesn't change much. Let's take an example. Let's go to the beach and bring our bathtub. So we get to the beach, we're sitting on the beach, and the bathtub's full. You hop in the bathtub, and then you go, it's kind of full, and you take out, say, 10 gallons of water out of that bathtub. Are you going to notice that 10-gallon change? Yes. But if you take that 10 gallons over and dump it in the ocean, are you going to be able to tell you changed the ocean's volume by 10 gallons? No. So that would be an idea of grounding, is that it makes a difference for something small, but it doesn't make a difference for something large. Okay? So we are going to ground, meaning I can just touch it because I'm a pretty big source compared to our electroscope we're dealing with here. So how it works is we remove charge when we ground it, and so then we give it the actual opposite charge. So let's work through these steps, and then we'll go ahead and take a look at the demo. So I'm going to bring in that charging rod, and I'm going to polarize my electroscope. I'm going to have those positive charges up at the top, and I'm going to push those negative charges down, and so I'm going to polarize it. I'm going to get those leaves to separate at the bottom there. Then I'm going to go ahead and touch it. I'm going to allow those extra electrons to go further away. They're going to be removed. I'm going to give this a neutral charge, but I'm still going to have a polarization up here at the top with the negative charges moving out and the positive staying there. And so after I've removed those negative charges, I'm going to remove the ground. Then I'm going to remove my arm. Because if I do it the other way, it's not going to work. Okay, as soon as I remove that wand, those electrons will come back from the ground and I'll be back to our neutral charge. So what I want to do is I want to remove that ground so those electrons can't come back. Now I can remove my charging wand. And so what I'll be left with is something that has missing electrons, and so it'll have an overall positive charge, and you'll see those leaves separate again. And again, we're going to go ahead and show how can I show that it's positive when we do that charging demonstration. So let's go ahead and take a look at that. All right, now we're going to do induction. So I'm going to go ahead and I'm going to charge up that rod, and I'm going to bring it in close. And remember, I'm polarizing. I'm trying to push those electrons away. And when I push those electrons away, I'm going to give them a place to go. And notice I have uncharged that sphere. Okay? Now those electrons are gone, and as I pull it away, you'll notice that those leaves widen out. Okay? They widen out more, so they are charged, and it's positive charge. Now, how do I know it's a positive charge? I know it's a positive charge because as I bring this in, I'm pushing the electrons down into the bottom, and it neutralizes those leaves as I push those electrons down into the bottom.